Web scraping means automatically gleaning data from the web. Welcome to this presentation about web scraping. In this presentation, we're going to show how to scrape yahoo.com in the financial section and grab data for 100 companies. We will grab data such as the trading date, the high price, the low price, the closing price, and the volume each day. We will use Python to do this. In the real world, web scraping is crucial as people try to do more and more data analytics. Why do we want to scrape data from websites? Well, web scraping is used to collect large amounts of information from websites. Services like ParseHub scrape data from online shopping websites and then use it to compare the price of products. Many companies that use email as a medium for marketing use web scraping to collect email IDs and then send out bulk emails. Web scraping is used to collect data from social media sites such as Twitter to find out what's trending. Web scraping is used to collect a large set of data from websites which are analyzed and used to carry out surveys, research, and development. Lastly, interviews are collected from different websites and then listed in one place. To delve further, what is web scraping and is it legal? Web scraping is an automated method used to extract large amounts of data from websites. The data on the websites are unstructured. Web scraping helps collect these unstructured data and store it in a structured form. There are different ways to scrape website, such as APIs or writing Python code. Here is the Python code that we are going to use for web scraping. This script is very long, so I'm going to break it into several sections. Here in this first part, I import several libraries, including PYODBC, which allows me to make connections to my database. I'm going to use CSV files. I need to use the pandas library, as we frequently do when we do data analytics and scraping, and a pandas data reader, date time, and time. Here in this section, then I have a connection string and I have an equal to these items. Now I blanked out the server and the password because I don't want to reveal those to everybody. Then I have a connection and then I define a cursor. Here in part 2, I create a table for company information. It looks small, but here is the create statement that I'm going to make. Then I have insert statements. There are a lot more than that are just on this page, but these are insert statements into the company information table. This first one is Apple, the name of the company Apple Incorporated, the fact that it is a tech industry, a phone number, an address, a city, a state, a zip, and country. So here is our Python code in the Jupyter Notebook environment. Here's my first section, and this is where I'm going to import the libraries that I need. So I will click Run, and now for this session, those are imported. Here is my third section of code. Now you might be wondering, what about the second section? The second section I already executed, but I didn't display it because it shows my username, IP address, and my password, and I didn't want to display that. This section of code includes table creation for company information right here, and we have 100 insert statements so that I can insert 100 companies into the company information table in SQL Server. So I will execute it. You'll see it changes color from green, and here at the top I know something's executed when I see this number 3 pop up. I didn't display the fourth area of code because it once again defines a connection string, and it's just like the one before, and I didn't want to reveal the password and the IP address of the server. Here in section 5, I set the variable query equal to, and this is going to be a select statement from the company information table that I already previously created. Then I have a variable called company information, and that's set equal to, here is my query, that's one of my arguments here, and the connection string was listed in section 4. I use the pandas library to read SQL so that it can execute this segment of code. Let's go ahead and run this, and it ran just fine. So here it is in the slide, and this section 4 was the one that I hid that builds a connection string and passes the server, the database, the user ID and password. Here is that snippet of code that we did for section 5 where we did the select and we used the pandas read SQL method. Now section 6 is going to simply be a list command, and it lists the first 5 rows. So let's go over to Python and look at that. So company information .head has the first 5 rows in this little batch of data that I created, and it includes a ticker symbol and an industry, and it's just for the first 5 ones. So we executed that, and then we see the output is just this little table. In this next section of code, we start pulling the data from the website Yahoo Finance. So in this particular example, we get data from January 1st, 2019 to July 31st, 2020. We did that here by setting the variable start equal to that January 1st, 2019, and we set end equal to the July 31st, 2020. Then I have a start time, and it grabs the time here, really because I want to see how long it takes to execute. So here I'm going to cycle through until I don't have any ticker symbols left, and I'm going to get data using the web reader method. Then I'm going to make sure that I get the ticker symbol company information. I'm also going to drop a column called adjusted close because I just wanted 4 columns. I wanted open, high, low, and close, and not the adjusted close. Then I will update my data frame that I have it in, and I will print how long it took to get all the data for the 100 stocks from January 1st, 2019 until July 31st, 2019. Here then is that section of code that I'm going to execute, and it will take about a minute to do this as it grabs the ticker symbol and all the rows for this date range, again for each of the 100 ticker symbols. So it ran, and we just look here and see that it took about 47 seconds to grab all that data. In this section of code, we're taking the data that we've already gleaned from the web and we're getting it in an order so that we can insert it into our SQL tables. So here we rename our columns, and then we merge our company information table with our stock data table, and that's just to get industry copied from company information into stock data where you have the same ticker symbol. Many would consider it bad design to have industry in the stock data table when it's already in the company information table. I do that because I like to show a lot of group by and aggregate queries, and it really helps in those queries to have it in stock data. Here at the end, we change the order of the columns to be the same order as they are in the SQL table. Let's run these sections of code then that are organizing and arranging the data internally in preparation for inserting them into our SQL Server table. We'll run this one. Here we rename the columns. Here we grab the industry from company information and put that into stock data table. And here we rearrange the order of the columns so that we can insert them into our SQL Server table. Here we connect again to our server, giving an ID, a password in the database, and we create the stock data table. So you can see that it will have a ticker symbol, an industry, trade date, open, high, low, close, and volume. And finally, we are going to connect to the server again with our server name, our database name, our user ID and password. We'll use the PYODBC library here to connect to the SQL Server database. And then we're going to insert into the SQL Server database from the pandas data frame here. We then commit, we close the cursor, and we close the connection. Now that we've scraped all this data from Yahoo Finance and we've inserted it into a table in an SQL database, let's go ahead and query that database and examine it. We'll execute that, and between 2019 and 2020, for the dates that we showed, and for the 100 total companies, we have about 39,000 rows of data. This is an example of scraping data from the web so that we can use it in SQL Server or any other relational database. Scraping data from the web is crucial in modern day data analytics. Analysts are continually scraping the web, getting all the data they can, and reacting as quickly as possible in order to make better decisions and to better approach the markets.